The strategic landscape of the Korean Peninsula in early 2026 remains defined by rapid technological escalation and the persistent need for multi-layered defense. On January 4, 2026, the Democratic People's Republic of Korea conducted its latest test of a hypersonic glide vehicle, once again shifting the focus toward the Republic of Korea Air Force and its ability to detect, track, and intercept high-velocity threats. While the fifth-generation F-35A and the domestically produced KF-21 Boramae often capture public attention, the backbone of South Korea's aerial defense continues to be the KF-16 fleet. Through a massive $1.2 billion modernization program, these aircraft are undergoing a transformation from legacy fourth-generation fighters into the KF-16U Viper, a platform equipped with the sensors and data-sharing capabilities required for the modern digital battlefield. The Republic of Korea Air Force currently operates one of the largest F-16 fleets in the world, consisting of approximately 134 KF-16CO D Block 52 aircraft and a smaller number of older F-16 PBU Block 32 models. By the start of 2026, official reports indicate that approximately 85% of the 134 KF-16s scheduled for the Viper upgrade have been delivered back to active service. This modernization is not merely a structural life extension, but a total overhaul of the aircraft's electronic nervous system. The primary objective is to ensure that these aircraft can operate seamlessly alongside fifth-generation assets and maintain a qualitative edge over regional adversaries who are increasingly fielding stealth aircraft and advanced cruise missiles. At the core of the KF-16U upgrade is the integration of the APG-83 Scalable Agile Beam Radar, also known as the Active Electronically Scanned Array Radar. This technology represents a generational leap over the previous AN's APG-68 V7 mechanically scanned radar. Unlike its predecessor, which utilized a moving antenna to sweep the sky, the Active Electronically Scanned Array Radar uses a stationary plate of nearly 1,000 small transmit/receive modules. These modules can steer energy beams at the speed of light, allowing the KF-16U to track dozens of targets simultaneously while continuing to search the horizon. For the South Korean audience, this capability is critical. It allows the aircraft to detect small, low-observable targets such as North Korean unmanned aerial vehicles or sea-skimming cruise missiles from distances exceeding 160 kilometers, nearly double the effective range of the original radar system. Furthermore, the APG-83 provides a high-resolution synthetic aperture radar mode. This allows pilots to generate photographic quality maps of the ground in all weather conditions, day or night. In the event of a conflict on the peninsula, this enables the KF-16U to identify and strike mobile missile launchers hidden in mountainous terrain with surgical precision. The reliability of this system is also significantly higher, as the lack of moving parts reduces the probability of mechanical failure during high-tempo combat operations. The increased flow of data from the new radar necessitated a complete redesign of the pilot's interface. The KF-16U features a new center pedestal display, a high-resolution color screen located between the pilot's knees. This display serves as a centralized hub for the Modular Mission Computer 7000AH, which possesses 10 times the processing power of the legacy system. In the previous cockpit configuration, pilots often struggled with information overload, having to mentally fuse data from multiple small monochrome screens. The new digital architecture performs this fusion automatically, presenting a unified tactical picture that identifies friends, foes, and neutral parties in real time. Connectivity is another pillar of the Viper upgrade. The inclusion of the Link 16 tactical data link allows the KF-16U to communicate directly with other high-value assets without using voice radio. A KF-16U patrolling over the East Sea can now receive target coordinates directly from a Navy Aegis-class destroyer or an E-737 Peace-Eye airborne early warning aircraft. This network-centric approach is vital for countering fifth-generation threats like the Chinese J-20. Even if a single KF-16U cannot defeat a stealth fighter in a direct head-on engagement, its ability to act as a forward sensor and relay data to ground-based interceptors or F-35s significantly complicates the adversary's mission. The modernization program also highlights the growing maturity of the South Korean defense industry, often referred to as K-Bangsan. While the core radar and computer systems are provided by Lockheed Martin and Northrop Grumman, the integration and maintenance are being handled by Korea Aerospace Industries. By 2025, a landmark agreement was reached to allow South Korean firms to manage the software updates and sustainment of the KF-16U fleet locally. This move toward self-reliance ensures that the Republic of Korea Air Force is not entirely dependent on foreign technicians during a national emergency. Central to this local integration is the ability to carry domestically developed munitions. The KF-16U is now being certified to carry the Cheonryong, Sky Dragon, air-to-ground cruise missile. With a range of 500 kilometers, this missile allows the KF-16U to strike high-value targets in the northernmost parts of the peninsula, while remaining safely within South Korean airspace. The integration of the Haeseong, Sea Star anti-ship missile also enhances the aircraft's role in maritime interdiction, providing a powerful deterrent against naval incursions in the West Sea. By arming an American-made airframe with South Korean-made claws, the Republic of Korea Air Force achieves a unique blend of proven performance and strategic autonomy. However, the path to modernization has not been without challenges. In March 2025, a publicized incident involving an accidental bomb drop during an exercise at the Pocheon Range raised questions about pilot training and the complexity of the new systems. Objective analysis by military experts suggested that the transition from analog-heavy cockpits to fully digital glass cockpits requires a fundamental shift in pilot psychology and muscle memory. In response, the Republic of Korea Air Force has invested heavily in advanced ground-based simulators that replicate the Viper's electronic warfare environment, ensuring that the human element remains as sharp as the technological one. Looking toward the end of the decade, the role of the KF-16U will evolve from a primary strike fighter to a versatile multi-role platform that bridges the gap between the aging F-4 and F-5 fleets and the incoming KF-21 Boramae. The synergy between the KF-16U and the KF-21 is expected to be a force multiplier. As the KF-21 enters full-scale production in 2026, it will often fly in mixed formations with the Viper. In such scenarios, the F-16's massive existing inventory of spare parts and proven airframe allow it to handle the heavy lifting of ordnance delivery, while the KF-21 utilizes its superior stealth characteristics for initial penetration. The $1.2 billion investment in the KF-16U Viper program ensures that South Korea maintains a credible deterrent in an increasingly volatile region. By focusing on sensor fusion, network-centric warfare, and the integration of domestic K-defense technology, the Republic of Korea Air Force has effectively reset the clock on its most numerous fighter type. While newer aircraft may capture the headlines, the Blue Dragon, in its new Viper skin, remains the silent, vigilant guardian of the Korean skies, capable of meeting the threats of 2026 and beyond.